Hey there, students. What I have for you here is a problem in which we are supposed to compare two population means. And this is number 22 on homework number 12, which is from chapter 9, and it's from section 2 of chapter 9. So in this problem it says a study was done using a treatment group and a placebo group. The results are shown in the table, so they have a little table with the summary stats here. Assume that the two samples are independent, simple random samples selected from normally distributed populations. And do not assume that the population standard deviations are equal. Complete parts A through A and B below. Use a 5% significance level for both parts. So in part A it says test the claim that the two samples are from populations with the same mean. So in this case, our claim is that the mean values are equal to each other. Often we have a claim that one is less than the other or one is greater than the other, but in this case we have a claim that the two are equal to each other. That would be similar to the claims that we did in chapter 8, where we claimed that a population value was equal to a specific number, but now we're claiming the two population means are equal to each other. All right, so the null hypothesis is always the one with equality. And so in this case, our claim that the group 1 is the treatment group, the group 2 or the population 2 is the placebo group. So our null hypothesis is that mu1 is equal to mu2, and that's offered in A and B here. And then when your claim is equality, then the alternate hypothesis is simply inequality. So in this case, that would be option A, where the alternate hypothesis is that mu1 is not equal to mu2. So I choose that. All right, so then to continue here, it says to find the test statistic. Now they're helping us a little bit because they're saying the test statistic T. So we know it's a T distribution. Just as a refresher, when you are making a claim about a population mean or means, if there's more than one population, and you do not know things about the standard deviation of the original population, then you use a T distribution. If we know that the two population standard deviations are equal in the comparison case, which they said we do not assume that, or if you're in a single population and you know the standard deviation of the population, then you use a Z distribution. But in this case, we're using a T distribution, and they gave us a little helpful hint by saying the test statistic T is when they ask us the question. So I'm going to go over to stat T stats. So previously in chapter 8 we had one sample, but now we have two samples, and they gave us summary stats here, so I'm going to go to with summary. So that was T stats, two sample with summary. So then they want the summary statistic information. So treatment 1, we have the sample mean was 2.31. The sample standard deviation was 0.65. And the sample size was 30. Then for sample 2, the mean was 2.65. Those are not two equal. Standard deviation of 0.97 and a group size, sample size of 39. So I'm double checking. It looks like I've entered these in correctly, just so that I don't have to redo the problem on a homework, or even worse, redo a whole quiz if it's a quiz, or even worse, just lose the points on a midterm because you can't redo them. Okay, so then it says perform the hypothesis test. So I have to make sure we have the hypothesis test. And again, in StatCrunch, their hypothesis tests are about the difference in the population values versus whether one is equal to the other. So if one is equal to the other, difference would be 0. That's the default. And in this case, if they were not equal to each other, that would just mean that the difference is not equal to 0. So that's all set, so I compute. So then they want the test statistic, and again, this is a T value, so the T stat here, we want to round to 2 decimal places. So I would copy that to 2 decimal places, looking like I need to round the 3 up to a 4 because it is followed by a 9. So let's make the 3 into a 4. Then they want the p-value to 3 decimal places. Again, I'm ending in a 6 that needs to be rounded up to a 7. So I'm rounding up again. And so then we have to state a conclusion. And so to draw a conclusion, we have the p-value. We compare that to the significance level. It says to use a 5% significance level, and our p-value is over 8%. So if the p is low, the null must go. But the p is not low enough. It's not below our significance level. So I'm unable to reject the null hypothesis. So I failed to reject the null. That option is offered in B and D. And when you fail to reject the null, it's because the sample gave you insufficient evidence to do so. So I failed to reject because there is not sufficient evidence. That's option D. Okay, so now in part B, they also want to do this with a confidence interval. And so I illustrated in an earlier example that we can just edit this so we don't have to enter any of this summary stats information again, and we switch from hypothesis over to confidence interval. Now we need to determine the correct confidence interval level. So in this case, again, we are testing a claim, and the claim we need to figure out if it's a one-tailed test or a two-tailed test, because the error rate, our significance level for error, is either all lumped into one tail on one side, or if it's a two-tailed test, then it's split between the two tails. And we have to figure that out to determine the appropriate confidence level. So in this case, we have a two-tailed test because our alternative claim is inequality, and you cannot be equal by being on the right or the left tail. On either side, you're not equal. And so for that reason, we want the 5% error for our significance level to be the total of the error, the area in both tails of our distribution confidence interval in the middle. And so if we split the 5% between both tails, that means in the middle, the rest is the other 95%. And that happens to be the default here. So for a two-tailed test at the 5% significance level, we want a 95% confidence interval, because if 95% of our assurance is in the middle here, then the other 5% where it's not equal is in the two tails. So I'm going to hit compute. And it's going to give me my confidence interval, and to 3 decimal places, the lower limit does not need to be rounded, so I can just drop that in there, and the upper limit also does not need to be rounded, so I can just drop that in there. And that's it.